Hi, I'm Mr. Miyagi, and this is Mr. Miyagi's Workshop. Stay tuned for the next episode of Parked When Ran. No, when ran, when parked. You know, you'll get it. Well, it's time to look at the clutch hub. This one here is off of 1973. This one here is off of a 1981. The difference between the two, let me get this, the inner rotating hub is a flat surface here. This takes, I believe, 7 fibers. This one takes 6 fibers. Now the difference on these is that we have a heavy-duty steel plate. We have basically a diaphragm and a guide ring. So the guide ring goes on, and then this goes down, and then the heavy, and I'm talking, this is fairly heavy in thickness compared to the standard plates. This is 0.062 thousandths is a standard. Let me get that to go on there. There we go. And the stock plates are 0.054 or 55. Now what I'm thinking is going on here is that since this has a little bit of give and such, is that on the older models they had what they called a cushion ring. And all that is a piece of rubber that goes in between the fiber, and let me take this one, between the fibers and the plates. So it rides right in here. So let me just open this up. This is pretty well stuck together. It's been together for a long time. There we go. And you can see there's the fiber, and then there's the cushion ring. So I think it is, they've had that in there due for shifting and everything working. The newer bikes will have literally a diaphragm similar to this, but with this style of teeth that fit on there for compression, and they actually use that for the spring setup. Anyway, this is going back in there. Now this is also kept in place by a wire, a little sealing wire that goes in, and it just has these little push-ins. So there's one spot where it gets in, and then there's a little groove that runs around this entire unit. And all it does is hold that lower steel plate in place. And these can be a real bit of a hassle to get on there, especially if you don't get them down in the groove. Okay, these are cleaning up pretty good. When you're miking these, to make sure that you got the right thickness and everything, these are all going to be running around, about 0.054 to 0.055. They say in the book that you can go down on these to about 0.050 within that. Normally every plate that I've ever grabbed, an old plate or anything, it's ran just right around 0.053 to 0.054. Now when you get into the fibers, these all run, what are they saying here? They're saying like a stock fiber should be 0.118, which is this one. And this is a used one, so it's 0.118. You need to replace these fibers if they get down to a 0.106. But most of them I've found usually run right around 0.118. Let's see what we got here. 0.117, 0.16, 116, 0.114, 0.116, 0.115. They average in there. These are all decent plates all the way through. I'll reuse all of these. I also have some other fiber plates or metal plates that I got off of some other bikes from years ago. See, now these steels are 0.055, so I know I'm flipping out a lot of information there, but standard are most likely your steel plates are going to be a 0.053 to a 0.055. Makes them good, they're okay. Fiber plates are going to average between, out there on most of the bikes that have been ran that you're going to find are going to run between a 0.114 to a 0.118. Now if they get down around a 0.106, you're going to have to end up replacing them. I hope that helps. I know it's a bit confusing, but there you have it. I'm a bit confused most of the time anyway. Okay, let's measure the springs. The spring tension on these. Now this measured at 1.653. And the book is saying 1.325. These are actually aftermarket springs, so they're a bit more tension on them. A lot of times guys will replace these, and just helps for a little bit more grab on the clutch. So why don't we install this clutch, and I'll show you how that goes. We'll put this on the motor that's being rebuilt right now. So hang in there, I'll be right back. One of the other upgrades I like to do, now this is what you'll end up finding in the stock bikes. You'll have a ball bearing here, this going into the little mechanical device that the clutch cable attaches to, a ball bearing in between the other push rod, and then there'll be another ball bearing between this and the clutch activator. So what I do is we get the long rod, and you can see that if you put this together that these are the same distance, but you still need the ball bearing at this end for the pivot and its riding and such. So there will be a ball bearing in there, otherwise you can't get the proper clutch adjustment. I just wanted to point that out. So this is what I upgrade to. I almost think that you get enough flex in there, you don't get a proper clutch movement when you go to the stiff rod like this. So it's just something to think about if you want to go that way. I mean, there's nothing wrong with the old system, but I just like a better performing hand clutch than I do the old style. It just seems to me that works a little better. Anyway, I just wanted to give you an update on that. So let's install the clutch, but we have to remove the Mickey Mouse blanket. So basically what we have another spacer that goes down on that bearing area down there. And then you'll have your center run, and then your hub itself. Drop it down. This is also gonna, when this slides on there, what you're trying to do is this gear right here is gonna ride on that gear right there. So now you're locked into the crank itself. After that, you have a thin washer that's going to fit around that spacer there, the rolling shim, then your bearing, your hub bearing, and then the other spacer. Now the inner clutch hub is going to go on somewhere along here. You got to get it lined up on. That's good to go. Now we're going to put on the fibers. So we already have a surface area for the fiber to run on the inside there. Then you apply another fiber, and you kind of want to look at these. You want the rounded end more up. So when these are stamped, there should be a more of a rounded edge right here that goes up. Same way with the steels. When these are stamped, it's got kind of a rounded edge, and on the back side it's a more straighted. You want to apply those with the rounded edge up. I know it's a little bit of a detail, but I just think that the clutch actually operates better if you do that. It won't hang up as much. Because I'm thinking if it's this way, if it cocks, it's going to jam. But if it's this way, it tends to want to slide. Just my theory. A lot of motorcycles, clutches will have, like this one's marked already for the outside, and it's the way I wanted it up anyway. But not happening here. I don't see anything on this, but this is the more rounded edge. I do this pretty much on all the motorcycles that I work on, even the old Harleys. I'll do the same thing and make sure that the plates are running in the same order. Okay, so how many plates we got there? We got 1, 2, 3, 4, 5, 6. Why is it? So what I like to do is there's a flat washer, little flat washer there. Some will actually have a lock washer and one of these. I put these down on there, and then I bought these lip up style that actually hook into the little grooves on the inner plate there. And then what I'll do is I'll put the nut on, and we'll tighten that down. And I'll show you what we do from there. Now I have this clutch unit. It'll help lock everything down. So when I'm tightening up everything, this just goes right in there. Now you can make one of these out of an old steel plate and attach something to it. This one here is just a cheap unit that I bought. I don't even know where the hell I got it, but it seems to work. On the locking ring, there's a little bit of a rise here, so all you have to do is grab that a little bit to lock the nut in place. So I'll just take a pair of channel locks and see if I can't grab that. Takes a little bit, just keep at it. And all we're doing is we're pulling that little piece up against the side of the nut. And we'll do this one on this side. And all this is doing is just making sure that the nut is not going to turn off or loosen up. So anyway, we're good to go there. So the next part that goes in there is your little push rod piece. But we also got to remember that there needs to be a ball bearing in there. So what I'm going to do is I'm going to take a little bit of grease, put in there, put that ball bearing in there, take this, lube this up a little bit, shove that down in there. Now that'll hold that ball bearing in place, or listen for it to hit the floor. And then I'll just apply a little bit of grease on the outside of this. Now, like I said, remember this little dot and that hole, we're going to line that up. And now the springs and everything can go together. So we drop the springs in, and then the spring holds. These take a little bit to get started. Now they do make some of these that aren't Phillip heads. You can buy the cool ones with the Allen head style. That's after you've gotten these all kind of screwed up. So I'll just get these to start, making sure that you don't cross thread. Bit of a pain if you do. All right, these are started. And then I've got my tool right here that I like to use. Okay, let's check out our charging system. We have a stator and we have a rotor. The rotor is attached to the crankshaft. It spins. The stator stays stationary. So how we have to check this out is that we need to use an ohm meter or a voltmeter with ohmage on it. I switched mine to 200 ohms. But first we want to do a test across here to see what resistance we have through this. I have a 0.9. Now whatever we measure on here, we have to subtract that 0.9. So if I'm going to do the rotor, I get a 6.2. So if I was going to subtract that, which would come up 5.3 ohms. Now on these units, from 5 to 7 ohms, they're good. So this is actually a good one. But another test you can do, and fun one to play with, take a 9-volt battery and go across your copper area and see if you can turn it into a magnet. Yeah, baby, it turns into a pretty good magnet, but just with 9 volts. Something fun to do anyway. So anyway, we know the rotor is in good shape. So let's move on to the stator. Stator has 3 wires that are white. These are the ones that you're going to end up having to test. So if we test across these, we end up getting 1.4 and another 1.4. So if we were to subtract the 0.9 from that, we should be getting right around about 0.5. Now these units are good if you get a reading between 0.4 ohms up to 1 ohm. So this is a good unit. One of the ways that this gets charged into a magnet is that there's 2 brushes in here that run on this surface here, and they're charged up. So one's the 12-volt side and one's the ground side. So that's what turns it into a magnet. Another thing is that there's a point on here for the newer models for these pickups in here for the electronic ignition. They pick up off of this point right here. So it's a charged unit and it activates the electronic points in there. Now I don't know whether I'm going to use the electronic ignition on this or I'm going to switch to a PAMCO with a mechanical advance or use a point setup with mechanical advance. I don't know that yet. I haven't really thought about it. It'd be an easy thing for me to do. All I'd have to do is remove the pickup point here and put the other units in or run this, but I'd have to run the little brain box. Now this system needs power. You have to have 12 volts to this to make it work at all so that everything will charge and run. If you go to the newer style system, the one of the latest upgrades, that would be a PMA, permanent magnet alternator. But then you don't really have to run a battery if you don't. You can run a battery eliminator if you want. But if you don't mind running a battery and you don't want to go to the expense of putting in a permanent magnet, these things work just fine, the stock units. And that's what we're putting back in. So let's install it. All right, we're going to install the rotor. But before we do anything, is we got to put in the little key that fits in the keyway here. Pay attention on that, and then slowly slide that down. Another thing I got to mention, I cleaned this up. I used some lightweight emery cloth and cleaned up the copper on here. It just sanded it, made it so it looked presentable, as they say. We're going to end up applying the lock washer and the nut. Okay, now the stator. This fits down in, there's a little pin located right in this area, right in here, right there. There's a pin sticking up. That lines up with this point right in here, and this will fit in the inside of that. If you ever get one of those permanent magnet setups, one thing you will have to do is you will have to remove that locating pin. Excellent. We're down. So the next stage, put our screws in. Mr. Tool. Oh, wrong tool. Wrong Mr. Tool. So what's kind of nice about using the original stator and rotor is that when you go to line up your cam chain or anything else that you need to line up or time this, it's already got its pre-marks and everything right in place there. So that's kind of nice. So, oh yeah, and then we have the one little seal that we want to make sure that goes down in between here and locks everything out. And then this will be worked in between all this, down, around, and up into whatever electronics and stuff or wiring that you're going to do. So that's pretty simple. It's pretty easy to take care of, to get to. If you need to replace these brushes in here, they sell those. You have to resolder them in place, but it's not a big deal. So, well, I hope this episode was entertaining for you. You learned something, and you had fun watching. If you've made it this far, thank you a lot. I really appreciate my subscribers and the people that watch my channel. But please like, share, and subscribe. And don't forget to hit that little ringy-dingy bell and push all so you can get all the latest updates on my episodes. If there's any questions or any comments that you want to do, please put them in the comment section below. I read them all. This is Mr. Miyagi signing off. So have a sweet day, stay safe out there, and don't forget to have some fun.